Hello, this is the Math 2460 Zoom meeting. I've got one participant. I can't see your name. You identify yourself again?
It's Madison.
Oh, okay, very good. We usually have other people join us as well. Let me walk through the assignments again for this week, and then we'll ask if you got any questions. I'm going to finish chapter 9. I know that breaks your hearts. No quiz this week over 9.9 and 9.10, but we'll have test 4 that'll cover all of chapter 9. I did mail out a review sheet. Same format as the other tests. The practice problems for 9.9, 3 to 25 odd. On 7 to 17, it gives you directions to find interval of convergence. Don't worry about that. That turns them into unbearable projects, and we will only mess with interval convergence back in, I think, in 9.8. So 9.10 to finish up, 5 to 15, 21 to 25, 27 to 39. And really only 2 web assigned problems from 9.9 I found worth doing. So when you have such small numbers, the percentages can get straight. If you only get one of them right, you get 50%, So it's almost 0, 50, or 100% on those things this week. Did you have any questions you wanted to ask? Oh, now we're up to 3 participants here. Any questions you want to ask? Would our other 2 people please tell me who you are? I can't see your names.
I don't have any questions, but are we going to go over 9.9 and 9.10 today?
Sure thing. Is that what you want to see, 9.9 and 9.10?
Yes, please.
Okay, no problem. (9.9) works off something, geometric power series. And if you remember what the geometric formula was back in 9.2, I believe. In other words, they're going to tell you what some of these random power series back in 9.8 were equal to. Geometric power series. I hope the Wi-Fi keeps working. It was a little rough last hour. Okay, do you remember your geometric series, 9.2? We had a summation, n equals 0 to infinity, a r to the n. And it wrote out a plus ar plus ar squared plus ar cubed, and so on. All right, if you remember, it had a sum of a over 1 minus r when the r was strictly less than 1. This ring a bell?
Yeah.
Okay, we're going to switch it around. Tried to show you this a little bit last section, but we couldn't do much with it. This means a over 1 minus r, and it expands to a plus ar plus a squared plus ar cubed. And this is called the power series expansion. All right, we want to put this in f of x form, make it look more like your standard function form. So we're going to set a equals 1 and r equals x. So we have 1 for that a, 1 minus x for this r. So everywhere there's an a, we stick a 1, which in effect makes it disappear. And everywhere we have an r, we stick an x. So we get 1 plus 1 times x, 1 times x squared, 1 times x cubed, 1 times x fourth, and so on. We'll call this f of x. This is our first basic formula. 1 over 1 minus x expands to this. Just to give you some confidence in this, give me a number for x, but it can't be any random number for x. Remember now our x is less than 1 because r is x. Give me a number less than 1, and we'll plug it in on both sides. Try to give you some confidence in this.
0.5.
How about 0.5? It's got to be less than 1. I heard 5. Can we make it 0.5?
Yes.
Okay. So we'll use x equals 0.5. 1 over 1 minus 0.5 is then 1 plus 0.5 plus 0.5 squared plus 0.5 cubed. I'll just carry out to a fourth power. You can work this side out in your head. 1 minus 0.5 is 0.5. 1 over 0.5, that's 1 over 1/2. That'll flip around to 2. Let's punch the other side. Plus 0.5 squared plus 0.5 to the third plus 0.5 to the fourth. Well, we're up to 1.9375. If I added on a 0.5 to the fifth, I get to, this is 0.5 to the fourth, 0.5 to the fifth. I'm up to 1.96875. If I use 0.5 to the sixth, add on 0.5 to the sixth, I'm up to 1.984. Is this enough to convince you that eventually I would get to 2 doing this? Everybody's so awestruck, you're speechless. This, by the way, is called the power series expansion of 1 over 1 minus x. It's our first basic formula. All of the homework in this section is going to work off this formula and the next formula I'm about to show you. The thing to notice about this formula, negative here means all positive signs here. Any questions about that, or can we go on?
We can go on.
Okay. Next formula. I'll rewrite this one. A 1 over 1 minus x has all positive signs in the power series. X cubed plus x fourth plus blah, 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 blah. We'll call this formula 1. Sub in x equals negative x. In effect, sub in a negative x. Call that formula 2. 1 over 1 minus a negative x. 1 plus a negative x here. A negative x squared. A negative x cubed. Negative x to the fourth. You see you get a 1 over 1 plus x. 2 negatives make it positive. And look what happens over here. A minus x. See that negative x squared, so negative even powers are going to stay positive. Odd powers on the negative will turn negative. Plus x fourth, and so on. So a positive sign here means the signs alternate. All of the homework in this section will pretty much work off these 2 basic formulas. Let's say nearly, there's some exceptions. Nearly all homework problems will work off these two formulas. I'll give you an example of what they want you to do. Here's an example. They'll say, find a power series for 1 over 1 plus x squared. Well, you know it matches formula 2 here. All you have to do is sub in x squared for x in formula 2. So 1 over 1 plus x squared would equal, see, I've replaced x with x squared, 1 minus x squared plus x squared squared. See, I'm putting in x squared for the x, but then that's squared, minus x squared cubed. See, I put in x squared for the x, but then it's cubed. X squared raised to the 4th, so on. If you simplify these out, you get 1 minus x squared, add x to the 4th, minus x to the 6th, plus x to the 8th. Signs still alternate because of this plus sign, but all the powers have turned even. This is the kind of stuff they want you to do. It's really not hard if you know these two basic formulas. Anybody have questions about that? See, the next thing they want you to do, the next example, they want you to find a power series for arctangent x. Well, it's almost like a progression here. If I can get both sheets on the thing, both formulas on. Remember, arctangent x was the antiderivative 1 over 1 plus x squared. This ring a bell?
Yes.
Everybody? Was that a yes?
Yes.
Okay. Well, I've just shown you that you can replace 1 over 1 plus x squared with that series. So I'm going to sub it in. Sub in. So I get an antiderivative 1 minus x squared plus x to the 4th minus x to the 6th plus x to the 8th dx. And you see, you've converted this to working by straight polynomial rule. So antiderivative on all these individual pieces, 1 brings back the x, you'd have x cubed over 3, x to the 5th over 5, x to the 7 over 7, plus x to the 9 over 9, and so on. Now, lest you think I'm completely making up this gibberish, look on page, it's actually 910. They actually show you this in 910, not 99 for some reason. Look on page 674. And there's arctangent x. And that is exactly the pieces that I just showed you. I get both of them on the screen. Barely there, and I don't know if I get this one on the screen as well, but yeah. X minus x cubed over 3 plus x to the 5th over 5 minus x to the 7 over 7 plus x to the 9 over 9. They give you a whole summary of these on this page. Power series for elementary functions. 1 over 1 plus x there, right there. That is your formula 2 I showed you. You can do one for e, sine, cosine. I've just shown you arctangent, also one for arcsine. The very last one's called binomial. That's works a little different. We'll show you that here in a minute. I don't hear any oohs and ahs. Are you so awestruck?
Yes.
Yes, okay. Is it time for some example homework problems?
That sounds good.
It really is not hard. Again, you've got to know these two basic formulas. Pretty much for most of them, these two basic formulas. This one comes off the straight geometric, all positive signs if that's negative, and this one alternating signs if that's positive. Let's show you what they want you to do. All right, so the very first homework, okay, starts at number 3. And notice that they give you a little variation on it. It's a 4 there instead of a 1. Now, I'm about to show you that what I've shown you is the techniques in example 1 and 2, part A. Then they want you to do it by long division. Okay, screw that. That's college algebra. We won't mess with long division. Okay, we'll just do part A. I should have pointed that out in the assignment. We're just going to do part A, not long division. Okay. So very first homework, 666. 3 part A, f of x, 1 over 4 minus x. Find a power series. Well, this most closely matches one over 1 minus x. And I'll just hope you got it memorized. It's all positive powers. But they want it with a 4, not a 1. Oh no, what am I going to do? I know the suspense must be killing you. Gee, how do I change the 4 to a 1 or the 1 here to a 4? All right, so start with 1 over 4 minus x. Factor out the 4. Well, that's a neat trick. So you get 1 over 4 in a parentheses, and you'd put a 1 there, so your 4 times 1 gives you 4. Oh no, there's no 4 here. I don't know if you remember this, we did this maybe once or twice earlier in. You do an x, but you'd have to divide by 4 to get it to multiply back. So now I got 4 times 1 is 4, and 4 times x over 4 leaves me my x. Any questions about this? Remember, that was what I called that formula 1. Make it really more obvious. I'm going to separate out the 1/4, big parentheses, 1 over 1 minus x over 4. Now, you see how I can match this to this? All I have to do is sub in x over 4 for x and put a coefficient of 1/4 on it. So I'm going to get a 1/4, and I'm going to sub in x over 4 where there's an x. 1 plus x over 4 plus x over 4 quantity squared, x over 4 quantity cubed, x over 4 quantity to the fourth, and so on. And this is my answer. All right. Do we need to pause for station identification? Everybody is so awestruck, nobody will say anything. I think Mr. Driscoll is our person who'll speak up most, and I don't think he's here today, so can't get anybody else to speak up.
In the book, they have the answer in a different form. So which one are you gonna have on?
Okay, good point. Let's look up the, yeah, I was going to mention that. That was my next thing to match. It's going to be tough to match the answers that you get like this with the book. Yes, let's look that up. We'll explain what they're doing. This is not, that was number 3 on 9-9.
Yes.
Okay, number 3 on 9-9. Yes. Book answer. 9.9, number 3. They have summation. X to the n, 4 to the n plus 1. Okay, you're going to see this through 9-9 and 9-10 a lot. Okay, how did they get this? Hell if I know. I'm not smart enough. They compress this back, and I think they like this form of the answer because it's a lot more compact, uses up a lot less space in the book to write it this way. Okay, I know that's frustrating. So about the only thing I can invite, I will accept, and only actually I'm going to work out the problems on the test and everything and show them expanded. I'm not going to compress them back. So I know that's frustrating. How do I know, you write out this form, how do I know if it's right? The only thing I can tell you to do is expand out their form and see if your pieces match. So if we do that, you'd have x to the 0 over 4 to the 1 plus x to the 1 over 4 squared plus x squared over 4 to the third. You see the pattern here. The power up here, the power down here is 1 bigger than the power on the x up there because it's n plus 1. So you'd have plus x cubed over 4 to the fourth. All right, still doesn't quite look like it's matched. So now you can either put your 1/4 through and see it really works, or you can factor out your 1/4. You take a 1/4 out, you'd have x to the 0 is 1. So you're going to lower these powers or factors by 1. So you'd have a plus x over 4 plus x squared over, let's see, your x stays the same if you only pull out a 1/4. So you'd have x squared over 4 squared plus x cubed over 4 to the third there, and so on. If you can see if it matches, I've just collected my thing all under 1 square. Does that help you match it?
Yes, that helps.
Okay. So yes, you can write your answers in this form, and on the test and quiz, remember you're going to be checking my work, and I will have the answers in this form. I won't compress them back to this form. Okay. That was, I don't hate to use the word easy one because it was centered around x is 0. When they start doing like something like number 7, this starts to put hair on your chest. And this is where I'm saying you don't have to determine the interval of convergence. It turns it into, a horrible problem. We're not going to mess with that. So C equals 1, that starts complicating your life a lot. Should we show you one of these? Are going to be more complicated. Should I show you that?
Yeah, we could do that.
sounds good.
Okay. Because they won't directly use Formula 1 or Formula 2. These are centered around 0. Remember, you're centered around whatever makes these individually 0. So you're centered around 0 here in both Formula 1 and Formula 2. Centered, can't even spell centered, around 0 here. Okay, so we won't directly use Formula 1 or Formula 2 at the start on these. This is page 666, problem 7. You've got f of x, 1 over 6 minus x, but your c equals 1. You're centered around 1. Remember, that's going to have factors of x minus 1. Meaning you're going to have an x minus 1 plus an x minus 1 squared, blah, 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 blah. That ring a bell? Because remember, you got to put this number into your thing. 1 minus 1 is 0. If it was c equal negative 1, you'd have factors of x plus 1. Everybody get that?
That makes sense.
Okay. So first thing, you want to change the centering. So you want to sub in x minus 1 for x. So you want your f of x here to be 1 over 6 minus an x minus 1. But you see, if I just go and use this, things have changed. I've got to, this is the hardest thing in the world to explain. I've got to fix this back to be equal to the original. Can you see how I've changed it? I've got 6 minus x, which matches here, but I've added in a plus 1. If you distribute this through, negative, negative 1 is a plus 1. The fix on this is going to be a minus 1. You see, there's not, you can't memorize this fix. You've got to, it's tough to teach jiggering in my head, but you've got to figure, gee, what did I do? I added in a plus 1, so I got to subtract 1. Do you see that this is equal to this? This and this are the same now. I can distribute it out and show you if it helps. See, you'd have 1 over 6 minus x, and the negative times negative is plus 1, so you need this minus 1. And now I have 1 over 6 minus x. Did that help? Everybody's so awestruck, nobody can speak.
So for each problem like this, do you just add whatever number would fix it? So
Yeah,
you fit-
it's just a matter, sub in the centering factor, and then you got to imagine, gee, what did I do? Just give you another idea. What if it had been centered around negative 3? Centered around negative 3. Just to give you another example. I'd have 1 over 6 minus an x plus 3. Because the factor would have been x plus 3. So negative 3 plus 3 is 0 here. All right, well, what have I done? I've got 1 over 6 minus x minus 3. So 1 over 6 minus x matches. See, all of this matches. I've got a negative. I'd have to add 3. to bring it back to 1 over 6 minus x. Does that make it any clearer, or is it still just gibberish?
That helps. So you just do whatever you need, no matter what the number is. That makes sense.
Yeah, you got to figure out how, in effect, by changing the centering, how did I screw this up? And then you've got to undo that to bring it back to this. And it's different on every problem. That's what makes it kind of tough. Okay, can I keep going?
Yes.
Okay. So basically, you want to you want to leave this alone because this clearly shows the centering. So you combine the terms around it, and that's 6 with the -1 there, you're going to get a 5. 5 minus an x minus 1. Now you're going to play that same game. Remember, I want to work it back to Formula 1 or Formula 2, which had a 1. So we're going to factor out the 5. 1 over 5, 1 minus x minus 1 divided by 5. You want to be really obvious with it, that's a 1/5, 1 over 1 minus x minus 1 divided by 5. Now, you see where I'm going with this? It matches 1 over 1 minus x, where this blob right here is generically the x. Remember, that's 1 plus x squared plus x cubed, blah, 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 blah. You see what I got to do? Front coefficient's 1/5, and I sub in x minus 1 over 5 for x. Are we ready to write that down? See if I can keep both. So I'd wind up with 1/5, 1 plus, for the x here, x minus 1 divided by 5. For the x squared, x minus 1 divided by 5, quantity squared. X minus 1 divided by 5, quantity cubed, and so on. And that's my answer, expanded answer. Do you want me to write down the compressed book answer and expand it out and show you get the same thing?
Sure, that would be helpful.
Okay. Number 7 for 9-9. The book gets this gibberish. Number 7. 5 over 5 raised to the n. All right, you can see you're factored out 1/5. See, I could put the 1/5 way in front, 1/5. All right, if n is 0, and all this to the 0 is going to give me 1. If n is 1, then I've got x minus 1 over 5. If n is 2, that's the n equal 1. This is n equals 0. N equal 2, and I'm at x minus 1 over 5 squared. N equal 3, I'm at x minus 1 over 5 cubed. And so on. Does that help?
Yes, that helps. Thank you.
Okay. Remember the directions also wanted you to find the interval of convergence for this. I'm letting you out of that. Please don't flood my email box with letters of email of undying gratitude for letting you out of finding the interval of convergence.
I'll try not to.
Very good. Thank you. Because if I had, if you went on and found your interval of convergence, remember that's full ratio tests. You'd have to do a ratio test on this, and then you'd have to check at check at the endpoints. Yeah, well, the endpoints come out of the ratio test. Whatever the ratio test shows you for endpoints, you then got to plug those. I mean, you'd be here another 30 minutes. I mean, seriously, it would, those are projects. Looking further down the page, is there anything else? 15 is going to be a project by itself, even though 15, they're centering it back at 0, so you don't have to mess with subbing in the x plus something, x minus something. You notice the form of this? You're going to have to factor that bottom and do a partial fraction expansion on it. 15 will be a project. Just to show you the kind of thing, a simpler version of 15 would be something like 19. In effect, in 19, they've already done the partial fraction expansion for you and gave you these pieces. You want an example of what they want you to do? Probably reads like gibberish to you, but it's pretty simple. You want an example of something like that? Where 36,
Yeah, can we go through that?
yeah, 19.
Yeah, that sounds good.
All right. Page 666, they give you that an h of x is a negative 2 over x squared minus 1, which is equal to 1 over 1 plus x plus 1 over 1 minus x. I hope you believe, apparently you do a partial fraction expansion on this and you'll get these two pieces. I hope you believe that. They're trying to give you a hint. Now, do you see that this directly matches formula 2 and this directly matches formula 1? Now, remember on formula 2, we wrote it, yeah, 1 over 1 plus, yeah, we wrote it exactly like this. Do I need to write them down individually, or can I just sub in the pieces?
You can just sub in.
Sub in, just to show you, reach back so I don't have to write them again. 1 over your 1 minus x is all positive signs, and 1 over your 1 plus x had the signs alternate. I'm just directly going to plug these in. That partial fraction expansion worked out directly these two formulas. So formula 2 there, signs alternated. And I'm just going to add right below it, because I'm out of room on the line anyway. This had all the signs positive. By writing them over each other, you can see the like terms. So when I add these up, 1 plus 1 is 2. And you see all the odd powers cancel. My x cancels, my x cubed cancels, my x to the 5th cancels. All the odd powers cancel. My even powers double. 2x to the 4th. You can see the pattern. I'll have a 2x to the 6th, a 2x to the 8th, and so on. It's really a matter of plugging and chugging and knowing your formulas. Do you want to see the answer to this? Remember, this is supposed to give me an approximation to negative 2 over x squared minus 1. Anybody want to give me an x and we'll plug in this and plug in this? Or do we all believe?
I think we all believe.
Because you see your calculator, if you wanted to use a formula, get a formula, an answer out of this formula on the calculator, your calculator is actually using this. It can't do this. You think it can because you can do it in your head if I give you a simple number, but the machine can only add, subtract, multiply, and divide. It can't work out something like this. The calculator is using this. Okay, so they'll give you some, like if you went to 21, you're going to wind up doing a derivative. They're giving you a hint. They want you to do a derivative on formula 2. 23 has you work out a log, and they're giving you the hint you do an antiderivative on formula 2. 25, 25 super simple, just to plug in x squared on formula 2. And in 27, that's simple. You plug in 4x squared on formula 2. But 15 will be a royal PITA, 15. That's going to be a royal PITA. Okay, is that enough for this section, and do you want to see something from 9:10 in our remaining minutes, or do you want to see any more examples from 9:9? I think Mr. Driscoll isn't
If you
here
start the introduction
to
to
9:10.
9:10.
You want an introduction to 9:10?
Yes, that sounds good.
Okay. Point 10 is called Taylor series. If you remember what we had in 9.7, we had Taylor polynomials. If you remember what the general Taylor formula was, f of c, f prime of c, see the useless crap I have in my head? X minus c squared. There's f triple prime of c over 3 factorial x minus c cubed. And they would tell you the end to tell you where to quit. Tells you where to quit. The power to quit at. This was given. But in 9:10, guess what the only difference is? For a Taylor series, won't give you the end because series implies infinite sum. So it's absolutely identical. You get f of c, f prime of c, x minus c, plus f double prime of c over 2 factorial squared. And it goes dot, dot, dot. It goes forever. But it works off the same principle, which makes 9.10 a repeat of 9.7. And yeah, if C is 0, they call it Maclaurin. Now, may do 1 or 2 of these, but after a while we get sick of this, and you can rely on page 676 for a lot of them. For a lot of the basic ones, you can rely on page 676 and really shorten them up. Etc. Do you want to see some of the homework for this then?
We can do that.
Okay. Well, I'll show you number 5 the long way. This is off page 677, 9.10. F of x is e to the 2x. C is 0. So notice that they're calling it Taylor. They're calling it a Taylor series, That's why McLaurin would probably get ticked, but he's been dead in the grave for 300 years, so he doesn't care, I guess. But notice generically, they're calling it Taylor. Okay, so we'll do it by the basic formula, then I'll show you how to shorten it up. Your basic formula f of x, e to the 2x, you would go f of 0, because your c is 0. In effect, I'm using these same form by plugging in c is 0. So when c is 0, you just give straight x, and you plug in 0 into all of these. F prime of 0x, f double prime of 0 over 2 factorial x squared. Triple prime of 0 over 3 factorial x cubed. I'll do one more, fourth over 4 factorial x to the 4th, and you technically add on dot, dot, dot. All right, if you remember how these work from 9-7, you make a table. If your f of x, start with the f of x is e to the 2x, your f of 0, you can tell is 1. E to the 2 times 0 is e to the 0, which is 1. F prime of x would be e to the 2x with a chain rule of 2. Your f prime of 0 would be 2. Your f prime of 0, so your e to the 0 is going to appear in every derivative. It will be 1 when I plug in 0, and you'll wind up with this chain rule term for your derivative value. Is e to the 2x times 2 and then times 2 again. So your f prime, double prime of 0 is going to be 4. So I'll do 2 more. F triple prime of x will be all of this. 2x times 2 times 2. So that's all of this, and then another 2. So your f triple prime of 0 is going to be 8. Can you tell your f fourth of 0 is going to be 16? X times 2, all of this, and then another 2, and your f fourth of 0 is going to be 16. That's probably enough pieces to show you. Are we losing anybody? So you plug and chug, sub in. You'd have f of 0 is 1 plus your f prime of 0 is 2x. Your f double prime of 0 is 4 over 2 factorial x squared. Your f triple prime is 8 over 3 factorial x cubed. And the last one is 16 over 4 factorial x to the 4th. Do you want to see the answer in the book? Matched out, or do you believe?
I think we believe.
Okay, now this is sort of the long way. Do you want to see the slick way?
Sounds good.
Page 674. See this series for e to the x. This is how your calculator computes e to the x. It does not take 2.718, raise it to some power. Can't do that. It plugs into this. Now, do you believe this formula, or do you want me to show you by what I just did, plugging into the straight Taylor formula, where this comes from, or do we believe?
I think we believe.
Okay, so let's start with that. E to the x has all positive powers. I'm copying this down from page 674. It's 1 plus x squared over 2 factorial, x cubed over 3 factorial, 4 factorial as far as I'll go. So guess what's the slick way? In this one, they wanted e to the 2x. Guess what the slick way of doing that is? Sub in 2x for what? X, right?
Oh, okay.
1 plus 2x for that x, plus 2x quantity squared for 2 factorial, 2x for that x cubed over 3 factorial, 2x to the 4th over 4 factorial. Now, it might be a little tougher. The 1 plus 2x matches directly. See, 2 squared there, there's your 4x squared over 2 factorial. 2 cubed, that's your 8x cubed over 3 factorial. 2 to the 4th is 16, x to the 4th over 4 factorial. Do you see the match?
I do.
See how much quicker that is?
Yeah, that's a lot easier.
So you're free. We can call this first way sort of first principles, and you're free to use it. Principles, but it might be this actually, principles. But yeah, if you can see a direct match, they give you a little variation off of a direct match, you're free to use it. We've already shown you Taylor. They made you do it the basic way in 9-7. We won't make you reinvent the wheel. You see the slick way, you can do it the slick way. Do you want to see any more examples? Like, look at sine of 3x, that's in 13. Again, the x is 0. Find a series. You want the long way or slick way? I'll give you your choice. Or you want both?
Why not go the easy way?
Okay. So I'm getting the mood of the room to do it the slick way. Page 674. I could use Taylor's formula and show you that a sine of x looks like this. It's got all odd powers. Sine of x minus x cubed over 3 factorial plus x fifth over 5 factorial minus x to the 7 over 7 factorial. Anybody want to see? You would derive this from Taylor's formula. I would be thrilled to show you. Anybody want to see it done? Any buddy out there leaping up and down? Yes, show me where this comes from. Or do we believe? Everybody's so awestruck.
I think we believe.
Okay, so if you want a sine of 3x, what do you think you would do? If you use a straight x and you get this, but you want it 3x, what do you think you'd do?
Do we just sub in and distribute the 3?
Yep, you just sub in 3x for the x in all of this. So you'd wind up with 3x minus 3x raised to the 3rd over 3 factorial plus 3x raised to the 5th over 5 factorial, 3x raised to the 7 over 7 factorial, plus 3x raised to the 9 over 9 factorial. That's all there is to it. Now, you may have a little bit of work matching the answer in the book, but that's basically all there is to it. I don't hear any oohs and ahs.
Makes things a lot easier.
Yeah. All right, we're at 55 minutes. That's a lot of stuff to throw at you. Have we opened up your heads and poured in enough? Or are you wanting to see more?
I think that was enough for today.
Okay. Remember, test 4 is Friday. Did everyone get the review sheet and key I mailed out?
Yes, sir.
Okay. So it'd be the same format. I'll add 10 points to the Google Form score. You'll decide true or false if the problem is worked correctly. It'll be test 4, will be available Friday and due Sunday. Anybody want to say anything else?
Is this our last test before the final?
No, we have a test on chapter 10. Chapter 10, I think you'll find is a lot easier than this. I think we're going to do chapter 10 all next week. It's just 3 sections. I think we'll cram it in all next week with a test at the end on it. It's all calculated work. It's pretty straightforward. I know you have a review sheet for it. It's that easy. And then, then we'll be running into Thanksgiving and come back after Thanksgiving for the final. And yeah, this semester goes in the history books.
Honestly.
You're on to your Calc 3 adventure.
Do you teach Calc 3?
Nope, I have never seen. I took Calc 3 probably in 1982 down at Tech, and I have never run into it since.
That's a shame.
I've never been assigned to teach it. We got enough Calc 3 teachers here. So you will run into whoever they've assigned it, but it won't be me because I literally would have to sit through it again to be able to teach it. And I'm not willing to do that.
I understand.
All right, anybody have anything else? All right, we'll hold another Zoom meeting Friday at 9 o'clock then. Hope to see you all there. Are we ready to end?
I think so.
Okay, well, thank you all for coming out this morning, and we'll hopefully see you on Friday. Thank you.
Thank you.